Hello, in this lecture we will find out the area of the semicircle using 4 different methods. In the drawing we have a semicircle that is inscribed by triangle ABC, blocks the semicircle. Triangle ABC is a right triangle. This angle ABC equals to 90 degrees. Side AB of triangle ABC equals to 12 units. Side CB of triangle ABC equals to 5 units. And we want to find out the area of this semicircle. So we will start with the first method. First of all, we will define the center of the semicircle as point O. Actually, OB is the radius of the semicircle because of the fact that line segment OB starts from the center of the semicircle, that is to say from point O, and ends at point B, that is a point on the semicircle itself. Therefore, OB is the radius of this semicircle, so we will define the radius of the semicircle as R. Therefore, AB will be equal to R, and we know that AB minus OB equals to AO again. I will write it down. AB minus OB equals to AO or OA. Okay? I repeat again. OA equals to AB minus OB. So we know that AB equals to 12 units. It is given us in the question. And OB is the radius of the semicircle, therefore it equals to R. So in conclusion, we found out that OA equals to 12 minus R. Okay. OA equals to AB minus BO, or OA equals to AB minus OB. AB is 12 and OB is R, so in conclusion, OA equals to 12 minus R. So we can write here that line segment OA equals to 12 minus R, and we will define the touching point between AC and the semicircle. This point is point D. Point D is the point of tangency of tangent AC with this semicircle. In the next step, we will join together points D and O by a straight line. Actually, DO, line segment DO, is the radius of this semicircle because of the fact that it starts from the center of the semicircle, that is to say from point O, and ends at point D, that is a point on the semicircle itself. Therefore, DO is the radius of the semicircle, that is to say it equals to R. And we know that ABC is a right triangle, so we will implement the Pythagoras theorem on the right triangle ABC in order to find out the value of its hypotenuse AC, or CA. Okay? So we will focus on the right triangle triangle ABC. In the right triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the right triangle ABC is CA, so the square of the hypotenuse is CA squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to CB squared plus AB squared. I repeat again. In the right triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, CA squared equals to CB squared plus AB squared. So actually, CA squared equals to CB squared. CB equals to 5 units. It is given us in the question. So CB squared is 5 squared. 5 squared is 25. Plus AB squared. It is given us in the question that AB equals to 12 units. Therefore, AB squared is 12 squared. 12 squared is 144. So in conclusion, we found out that according to equation number 1, CA squared equals to 25 plus 144. 25 plus 144 equals to 169. So we got that CA squared equals to 169. Here we will take a root out of this equation number 1, and we will get that CA equals to the square root of 169 and the square root of 169 is 13. So we found out that CA equals to 13 units. The hypotenuse of triangle ABC, according to equation number 1, equals to 13 units. So we can write here that CA, the hypotenuse of triangle ABC, equals to 13 units. In the next step, I will present to you a new rule, rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So I'll repeat on rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have a circle and the center of this circle is at this point. We'll define the center of the circle as point O, and we also have tangent to this circle. Actually, tangent AB is tangent to this circle at this point. This is the point of tendency. We will define the point of tendency as point M. So point M is the point of tendency of tangent AB with this circle. We will join together points O and M by a straight line. OM is the radius of this circle. We define it as R. So we have here the radius OM is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. I will repeat on rule number 1 again. A tangent to a circle, that is to say, tangent AB, is perpendicular to the radius drawn to its point of tangency. So whenever you have a radius, like in this drawing, the radius OM is drawn to the point of tangency, therefore the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, according to rule number 1. So we can implement rule number 1 in our drawing, because in our drawing we have this radius. The radius, we know that point D is the point of tendency of tangent CA with this semicircle, and we have this radius. The radius OD is drawn to the point of tendency, that is to say, it is drawn to point D, that is the point of tendency of tangent CA with this semicircle. Therefore, the tangent CA will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, according to rule number 1. And in the next step, we will focus on the right triangle, triangle ABC, and also on the right green triangle, triangle ADO. This right triangle, triangle ADO, and the big right triangle, triangle ABC. And we will prove that those two right triangles are similar to each other. Okay? I'll repeat again. We will focus on the right triangle, triangle ABC. And the green right triangle, triangle ADO. And we prove that those two right triangles are similar to each other. Okay, so first of all, we know that those two angles, they are both right angles, therefore they are equal to each other. So this angle is angle ABC in triangle ABC. And it equals to this angle in the green triangle, triangle ADO. In this angle, it is actually angle ADO. And both those angles are right angles, that is to say, they are equal to 90 degrees. So, you can write down that angle ABC equals to angle ADO, and both angles are right angles. That is to say, they are equal to 90 degrees. Okay? And we also have this angle, angle CAB. Angle CAB is a common angle. It belongs both to the big right triangle, triangle ABC, and angle CAB also belongs to the green triangle. So we can write down that angle A equals to itself, angle A equals to angle A. It's a common angle that belongs to both triangles. I will repeat again. Angle A angle A equals to angle A. It's a common angle that belongs to both triangles. And those two angles, they are also equal to each other according to third angle theorem. So this angle is angle ACB in triangle ABC, and it equals to this angle, that is actually angle AOD in the green triangle. And they are equal to each other according to third angle theorem. I'll repeat again. Angle ACB equals to angle ADO, and they are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. Why? Because it is complementary to 180 degrees. Because we know that sum of the angles in any triangle is equal to 180 degrees, and the first pair of angles are complementary to 180 degrees. So here we have actually those two angles in triangle ABC congruent to those two angles in the green triangle. Therefore, we have two pairs of angles that congruent in triangle ABC and the green triangle. Therefore, the first pair of angles must be also equal or congruent because they are complementary to 180 degrees. Therefore, they must be equal to each other. Okay, so we actually proved that all three angles in triangle ABC congruent to all three angles in the green triangle. Therefore, we can conclude from it that triangle ABC is similar to triangle, the green triangle, triangle ADO, according to angle similarity rule. So I will write it down. We actually proved that triangle ABC is similar. This is the sign of similar to triangle ADO, the green triangle, and they are similar to each other according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all angles in one triangle can go into all two angles in another triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. Okay, and from the fact that triangle ABC is similar to the green triangle, triangle ADO, we will conclude that CB over CA in triangle ABC, CB over CA in triangle ABC equals to DO over OA in the green triangle. DO over OA in the green triangle, triangle DAO. I'll repeat again. From the fact that triangle ABC is similar to the green triangle, we will conclude that CB over CA in the green triangle is equal to DO over OA in the CB over CA in triangle ABC is equal to DO over OA in the green triangle, triangle ODA. Okay, and we know that CB equals to 5 units. We have already found that CA, the hypotenuse of triangle ABC, equals to 13 units, and it equals to DO. DO is equal to R, it is the radius of the semicircle, that is to say it equals to R over OA. We have already found out that OA equals to 12 minus R. So in conclusion, we found out that according to equation number 2, 5 over 13 equals to R over 12 minus R. We will cross multiply equation number 2 and we will get that 5 times 12 minus R equals to 13R. Here we will open the brackets on this side of equation number 2 and we will get that 5 times 12 is 60, 5 times minus R is minus 5R, and it equals to 13R. Here we will add 5R to this equation number 2, and we will get that 13R plus 5R is 18R, and 5R plus minus 5R is 0, so 18R equals to 60. Here we will divide equation number 2 by 18, and we will get that the radius of the semicircle equals to 60 over 18. Here we will divide both the numerator and the denominator of this number by 6, and we will get that 60 over 6 is 10, and 18 over 6 is 3. So in conclusion, we found out that the radius of the semicircle, according to equation number 2, equals to 10 over 3 units. The radius of the semicircle equals to 10 over 3 units. So, and the area of the semicircle is equal to pi r squared over 2. I'll repeat again. The area of the semicircle is equal to pi r squared over 2. So it is pi, and r is 10 over 3. R squared is 10 over 3 squared over 2. So the area of the semicircle equals to pi. 10 over 3 squared is 100 over 9, all divided by 2. 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. The bracket is the sign for the area, so the area of the semicircle so this sign means the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers it equals to 17.45 square units. So we finished with the first method. In the next step I will present to you how to find out the area of this semicircle according to the second method. In the second method, I will present to you a new rule, and we'll implement the rule in our drawing. The new rule is actually rule number 2, or 2 tangents theorem. Rule number 2 states that rule number 2, or 2 tangents theorem, according to rule number 2, the lengths of 2 tangents from a common external point to a circle are equal. So I will read rule number 2 of 2 tangents theorem again. According to rule number 2, the lengths of 2 tangents from a common external point to a circle are equal. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have a circle and we have this point P. Point P is defined as an external point in relation to this circle, or it is an external point of this circle. Why point P is an external point? Because of the fact that point P is not located inside this circle nor on this circle, but it is located outside of this circle. Therefore it is defined as an external point of this circle. So if from the external point P we will draw 2 tangents to this circle, the first tangent will be this tangent we will define the point of tangency of the first tangent with the circle as point A, and we will draw the second tangent to this circle from point P, and we will define the point of tangency of the second tangent with this circle as point B, and according to rule number 2, the lengths of two tangents, in this case the length of the first tangent is PA, and the length of the second tangent is PB, and according to rule number 2, the lengths of two tangents from a common external point, the common external point is point P, so the length of two tangents from point P to the circle are equal. That is to say, PA equals to PB. It means that whenever you draw two tangents to a circle from a common external point of that circle, then the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. Okay? And we can actually implement rule number 2 or two tangents theorem in our drawing, because in our drawing we have the external point C, and from the external point C we have two tangents to this circle. The first tangent is tangent CB. CB is tangent to the semicircle at point B, and the second tangent, it is actually C. We define the touching point between the tangent CA and this circle as point D. So the point of tangency of tangent CA, if this semicircle, is defined as point D. So the length of the second tangent from point C, it is actually CD. And okay, the length of this tangent from point C to the circle is CD, and the length of the first tangent from point C to the circle is CB, and according to rule number 2, the length of those two tangents that exit from the external point of the circle to this semicircle, the lengths are equal to each other. That is to say, CB equals to CD according to rule number 2. But it is given us the question that CB equals to 5 units. So I can write here that CB equals to 5 units. And from this equation, we will get that CD also equals to 5 units. Okay, we will get that CD also equals to 5 units. So we can write here that CD, this line segment, this CD or DC equals to 5 units. And here we know that the center of the semicircle is at point O. OB is the radius. AO, we already found out in method 1 that AO equals to 12 minus R. And Here, DO is the radius of the semicircle, and we have already found out that according to rule number 1, those two angles are right angles, that is to say this angle equals to 90 degrees, and this angle is also equal to 90 degrees. And actually, you can see here that what is the length of AD or DA? DA equals to CA minus CD again. CA minus CD equals to DA. Okay? So we can write down that DA equals to CA minus CD. It is very clear to see it from the drawing that DA equals to CA minus CD. So DA equals to CA is 13 units, and CD, we just right now found out that CD equals to 5 units. And CA equals to 13 units. We found it in method 1 that CA, the hypotenuse of the right triangle, triangle ABC equals to 13 units. And we just right now found that CD or DC equals to 5 units. So DA equals to CA, that is 13 units, minus CD, that is 5 units. And 13 minus 5 equals to 8. So we found out that DA equals to 8 units. So we can write here that DA equals to 8 units. So in the next step we will focus on the right triangle, triangle ADO, the right green triangle, triangle ADO. And we will implement the Pythagoras theorem on the right green triangle, triangle ADO. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right green triangle, triangle ADO, we will get that according to the Pythagoras theorem, the hypotenuse in the right green triangle, triangle ADO is OA because it is in front of the right angle. So the hypotenuse is OA. So the square of the hypotenuse is OA square. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to DO square. We know that DO is the radius of the semicircle. We found it in method 1. So it equals to DO square. So it equals to R. It equals to the sum of the squares of the perpendiculars, that is to say it equals to DO square plus AD square. So I repeat again, in the right plane triangle, triangle ADO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say OA square equals to DO square plus AD square. But we have already found out that OA equals to 12 minus R, therefore OA square is equal to 12 minus R square. And it equals to DO square, it equals to DO square, that is actually DO equals to R, so DO square is R square, plus AD square. AD equals to 8, so AD square is 8 square, and 8 square is 64. So in conclusion, we found out that according to equation number 1, 12 minus r squared equals to r squared plus 64. We will open the brackets on this side of equation number 1, and we will get that 12 minus r squared is equals to 12 squared, that is 144, plus r squared minus 24r, and it equals to r squared plus 64. So here we have r squared on both sides of equation number 1, so r squared will get cancelled. And what is left from equation number 1 after we cancelled r squared? What is left? It is actually in this side of equation number 1, we have only 144 minus 24r, and in the other side we have only 64. We will subtract 64 from this equation, equation number 1, and we will get that 144 minus 64 is 80, minus 24r equals to 0. We will add 24r to this equation, equation number 1, and we will get that 24r equals to 80. Here we will divide equation number 1 by 24, and we will get that r equals to 80 over 24. Here we will divide both the numerator and the denominator of this number by 8, and we will get that 80 over 8 is 10, and 24 over 8 is 3. So in conclusion, we found out that according to equation number 1, the radius of the semicircle equals to 10 over 3 units, and therefore the area of the semicircle will be equal to pi r squared over 2, pi r squared over 2. R is 10 over 3, so pi times 10 over r squared is 10 over 3 squared, all divided by 2. 10 over 3 squared is 100 over 9, all divided by 2. And 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, so we finished with the second method. In the next step, I will present to you how to find out the area of this semicircle according to the third method. Okay? So here, we'll just, I will not repeat on the things that I did in the method 2 and the second method. We know that this point is point O. This equals to R. AO is 12 minus R. And we also know that this point is point D. And DO is the radius of the semicircle. It equals to R. And this angle is a right angle. Those two angles are right angles. And we also know that AC equals to 13 units, the hypotenuse of triangle ABC. So here, so those things we did in the first two methods. I will not repeat on it. And what we will do in the third method, we just, actually, we will draw a mirror image of this figure. I will repeat again, we will draw a mirror image of this figure, and then we will join together this image with its mirror image. And in this way we will get a circle that is inscribed by a triangle. Okay, so I will draw this image with its mirror image together. Okay, and we will actually get a triangle that blocks this circle. Know that AB equals to 12 units, AC equals to 13 units, and we will define this vertex as point D. I repeat again, I drew the original image, this image, with its mirror image, and I joined them together. I joined them together, and in this way we got triangle ADC that blocks this circle, and we know that AB equals to 12 units, AC equals to 12 units, and because of the fact that this side is the mirror image of this side, then AD will be also equal to 13 units. We know it is given us the question that BC equals to 5 units, and because of the fact that this is the mirror image of this image, then DB will be equal to BC, so BC equals to 5 units, therefore BD will be also equal to 5 units, therefore side BC of triangle ABC of triangle ADC will be equal to 5 plus 5, that is to say it will be equal to 10 units. Okay, so the base of the isosceles triangle, triangle ADC, is equal to 10 units, and the height to the base, it is AB, that equals to 12 units, and the area of the isosceles triangle, triangle ADC, will be equal to the base of the triangle. This is the sign of the area. The brackets means the area of triangle ADC will be equal to the base of the triangle times the height to the base over 2. Okay, so the area it is the area of any triangle, yes, and the area of our triangle, triangle ADC, the isosceles triangle, triangle ADC, will be equal to the base of triangle ABC, of triangle ADC is BC, it is DC. DC is the base. The height to the base is AB, because the height must create 90 degrees with the base, and indeed AB creates 90 degrees with the base DC, so it is AB. The height is AB over 2. So the area of triangle ADC, the isosceles triangle, triangle ADC, is equal to DC equals to 10 units. We already found out that DC equals to 10 units. It is given us the question that AB equals to 12 units over 2. All divided by 2. So 10 times 12 is 120, and 120 over 2 is 60. So we found out that the area of triangle ADC is equal to 60 square units. Okay? And we know that the radius of any circle that is inscribed by a triangle, like in this drawing, we have this circle that is inscribed by triangle ADC, and the radius of this circle will be equal to the area of the triangle that blocks the circle, that is to say the area of triangle ADC, over the perimeter, over the semi-perimeter of triangle ADC. So I will write down the formula for the radius of this circle. The radius of this circle that is inscribed by triangle ADC will be equal, R will be equal to the area of triangle ADC that we already found out that is equal to 60 square units over the semi-perimeter of triangle ADC. And the semi-perimeter of any triangle is equal to the perimeter over 2. And the perimeter of triangle ADC equals to the sum of its sides, that is to say AD plus AC plus DC over 2. I will repeat again. The perimeter, the semi-perimeter of triangle ADC equals to the sum of its sides over 2. That is to say it is AD plus AC plus DC over 2. AD is 13, AC is 13, DC is 10, all divided by 2. 13 plus 13 is 26, 26 plus 10, 26 plus 10 is 36, and 36 over 2 is 18. So we found out that the semi-perimeter of triangle ADC equals to 18, and we already found out that the area of triangle ADC equals to 60 square units. So the radius of the semicircle equals to 60 over 18. Actually, the radius of the circle, it is also the radius of the semicircle, because the circle is the combination of the of two semicircles. Okay, so we'll divide both the numerator and the denominator of this number by 6, and we'll get that 60 over 6 is 10 and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units, and the area of the semicircle equals to pi r squared over 2, that is to say it equals to pi, r is 10 over 3, so r squared is 10 over 3 squared, all divided by 2, so it is actually pi, 10 over 3 squared is 100 over 9, all divided by 2, 10 over 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. We finished with the third method. In the next step, I will present to you how to find out the area of this semicircle according to the fourth method. We know that the center of the semicircle is O. OB equals to R. AO equals to 12 minus R. We already did it in the previous methods. Here OD is also equals to R, the radius of the semicircle. Those two angles are right angles. We have already found out that AC equals to 13 units. So here in the third method, in the fourth method, Now we'll find out the area of this semicircle according to the fourth method. In the fourth method, we will define angle CAB, this angle is angle theta, and we will focus on the right triangle, triangle ABC. On the right triangle, triangle ABC, sinus theta is equal to CB over CA. I repeat again, on the right triangle, triangle ABC, sinus theta equals to CB over CA, and we know that CB equals to 5 units and CA equals to 13 units. So in conclusion, we found out that according to equation number 1, sinus theta equals to 5 over 13. In the next step, we will focus on the green right triangle, triangle ADO. In the green right triangle, triangle ADO, what is the value of sinus theta? You can see that in the green right triangle, triangle ADO, sinus theta equals to DO over AO. I repeat again, on the green right triangle, triangle ADO, sinus theta equals to DO over AO, but we know that DO equals to R and AO equals to 12 minus R. So in conclusion, we found out that according to equation number 2, sinus theta equals to R over 12 minus R. So we will create equation number 3 that states, equation number 3 states that sinus theta according to equation number 1 that equals to 5 over 13 must be equal to sinus theta according to equation number 2 that equals to R over 12 minus R. Okay, I'll repeat again. Equation number 3 states that sinus theta according to equation number 1 that is actually 5 over 13 must be equal to sinus theta according to equation number 2 that is actually R over 12 minus R. Here we will multiply equation number, we will cross multiply equation number 3 and we will get that five times 12 minus R equals to 13R. Here we will open the brackets of this side of equation number 2 and we will get that 5 times 12 is 60, 5 times minus R is minus 5R, and it equals to 13R. Here we will add 5R to this equation, equation number 2, and we will get that 13R plus 5R is 18R. 18R equals to 60. We'll divide this equation number 3, by 18, and we'll get that the radius of the semicircle equals to 60 over 18. Here we will divide both the numerator and the denominator of this number by 6, and we will get that 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units, and therefore the area of the semicircle equals to pi r squared, equals to pi r squared over 2. I repeat again, the area of the semicircle equals to pi r squared over 2, because it is a semicircle, therefore its area is half the area of the circle, therefore it is pi r squared over 2, and r is 3 over 10, 10 over 3, 10 over 3, so r squared is 10 over 3 squared, all divided by 2, so it is pi, 10 over 3 squared is 100 over 9, all divided by 2, 100 over 2 is 50, so in conclusion we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, so we finished with the fourth method. In the next step I will summarize the lecture. Actually we wanted to find out the area of this semicircle, and we found it in 4 different methods. In the first method, we have here a semicircle that is described by the right triangle ABC. We know that CB equals to 5 units, AB equals to 12 units, and we want to find out the area of the semicircle. Triangle ABC is a right triangle, angle ABC equals to 90 degrees. So we define the center of this semicircle as point O, and we define the touching point between tangent CA and the semicircle as point D. We join points O and D together by a straight line. OD is the radius, OB is also the radius. And what is the value of AO? The value of AO or OA, it equals to AB minus OB. Again, AB minus OB equals to OA. OA equals to AB minus OB. AB equals to 12 units. It is given us the question. OB is R. So OA equals to AB, that is 12, minus OB, that is R. That is to say OA equals to 12 minus R. Then we focused on the right triangle ABC in order to find out the value, the length of the hypotenuse CA. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say CA square equals to CB square plus AB square. So CA square equals to CB square. CB equals to 5 units. So CB square is 5 square. 5 square is 25. Plus AB square. AB equals to 12 units. It is given us in the question. So AB square is 12 square. 12 square is 144. So in conclusion, we found out that according to equation number 1, CA square equals to 25 plus 144. 25 plus 144 is 169. Here we took a root out of this equation number 1, and we got that CA equals to the square root of 169, and the square root of 169 is 13. That is to say, the hypotenuse CA of triangle ABC equals to 13 units. And then I presented to you a new rule. Rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and tangent AB is tangent to this circle at point M. Point M is the point of tendency of tangent AB with this circle, and OM is the radius of this circle. You can see that the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? So whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. So this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. And we can implement rule number 1 in our drawing, because in our drawing we have the radius OD, it is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of tangent CA with this semicircle. Therefore, the tangent CA will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? Then we proved that the triangle ABC is similar to the green triangle ADO. Why they are similar to each other? Because of the fact that those two angles, they are equal to each other, they are both right angles. So angle ABC of triangle ABC equals to angle ADO of the green triangle, and they are both equal to 90 degrees. Angle A is a common angle, it belongs to both triangles, so angle A is equal to angle A, is a common angle. And those two angles, they are equal to each other according to third angle theorem. And what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And we have those two angles in triangle ABC that congruent to those two angles in the green triangle. Therefore, we have two pairs of angles that are congruent in those two angles. Therefore, the third pair of angles, those are the third pair of angles, must also congruent because they are complementary to 180 degrees. Okay, therefore, angle ACB equals to angle AOD. Those two angles are equal to each other according to third angle theorem. So we proved that all three angles in triangle ABC can go into all three angles in the green triangle. Therefore, triangle ABC is similar to triangle, this is the sign of similar, triangle ABC is similar to triangle AOD according to angle similarity rule. And what is angle similarity rule? Angle similarity rule is that if you have if all the angles inside one triangle can go into all two angles in another triangle, then those two triangles are similar to each other according to angle similarity rule. And from the fact that triangle ABC is similar to the green triangle, we will conclude that CB over CA in triangle ABC, here CB over CA in triangle ABC is equal to DO over AO in the green triangle. Again, CB over CA in triangle ABC equals to DO over OA in the green triangle. Okay? CB equals to 5 units, CA equals to 13 units, DO equals to R, and OA equals to 12 minus R. So we got this equation that 5 over 13 equals to R over 12 minus R. We multiply this equation number 2, and we got that 5 times 12 minus R equals to 13R. We open the brackets on this side of equation number 2, and we got that 5 times 12 is 60, and 5 times minus R is minus 5R. Here we added 5r to this equation number 2, and we got that 13r plus 5r is 18r. So in total we got, in conclusion, we got that 18r equals to 60. We divided this equation number 2 by 18, and we got that r equals to 60 over 18. And we divided both the numerator and the denominator of this number by 6. 60 over 6 is 10, and 18 over 6 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units. And therefore, the area of the semicircle will be equal to pi r squared over 2. Pi times r is 10 over 3, r squared is 10 over 3 squared over 2. 10 over 3 squared is 100 over 9. So in conclusion, we found out that the area of the semicircle equals to 100 times pi over 2 over 9. 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the second method. Finished with the first method. We finished with the first method, and in the next step, I actually presented to you how to find out the area of the semicircle according to the second method. In the second method, we actually used rule number 2, or 2 tangents theorem. According to 2 tangents theorem, the lengths of 2 tangents from a common external point to a circle are equal. What is the meaning of rule number 2, or 2 tangents theorem? The meaning of rule number 2 is that if we have this circle and we have external point, point P is an external point, if we draw 2 tangents to this circle, tangent PA and tangent PB, then the lengths of those 2 tangents will be equal to each other. That is to say, PA equals to PB. So whenever you have an external point of a circle and you draw 2 tangents to that circle, then the lengths of those 2 tangents will be equal to each other. In this case, PA will be equal to PB. We can implement rule number 2 in our drawing, because in our drawing we have the external point, point C, and from point C we have 2 tangents to this circle. The first tangent is tangent CB, and the second tangent is tangent CD, and according to rule number 2, they are equal to each other. That is to say, CB equals to CD, according to rule number 2, but we know that CB equals to 5 units. It is given us in the question. So we can write here that CB equals to 5 units, according to what is given us in the question. And from this equation, we will get that CD also equals to 5 units. Here, CD equals to 5 units. And what is the value of AD? AD equals to AC minus DC. AC minus DC equals to AD. DA or AD equals to AC minus CD. AC is 13, CD is 5. So DA equals to 13 minus 5. 13 minus 5 is 8. So we found out that DA equals to 8 units. Then we focused on the green right triangle, and we implemented the Pythagoras theorem on the green right triangle, triangle DAO. According to the Pythagoras theorem, in the green right triangle, triangle DAO, the square of the hypotenuse equals to the sum of the square of the perpendiculars. That is to say, OA square equals to DO square plus AD square. AO equals to 12 minus R, so AO square equals to 12 minus R square. DO equals to R, so DO square equals to R square. AD equals to 8, so AD square is 8 square. 8 square is 64. We open the brackets on this side of equation number 1. 12 minus R square is 12 square is 144 plus R square minus 24R, and it equals to R square plus 64. We have R square on both sides of equation number 1, so R square will get cancelled. what is left from equation number 1 after we cancelled r squared? What is left is actually 144 minus 24r equals to 64. We subtracted 64 from this equation number 1, and we got that 144 minus 64 equals to 80, so we got that 80 minus 24r equals to 0. We added 24r to this equation number 1, and we got that 24r equals to 80. Here we divided equation number 1 by 24, and we got that the radius of the semicircle equals to 80 over 20. 80 over 24. Here we divided both the numerator and the denominator of this number by 8, and we got that 80 over 8 is 10, and 24 over 8 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units, and therefore the area of the semicircle equals to pi r squared over 2. R is 10 over 3, so r squared is 10 over 3 square, and 10 over 3 square is 100 over 9. So we got that pi times 100 over 9 over 2 equals to the area of the semicircle. 100 over 2 is 50, so in conclusion we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers it equals to 17.45 square units. So we finished with the second method, and then I presented to you how to find out the area of the semicircle according to the third method. In the third method, I actually drew the mirror image of this figure, and then I combined this original image with its mirror image, and in this way we got a circle that is inscribed by triangle. Okay, here I draw the original image with its mirror image together. In this way we got this circle that is inscribed by triangle ADC. We know that AB equals to 12 units, AC equals to 13 units, and because of the fact that this image is the mirror image of this image, then BC will be equal to BD, so BC equals to 5 units, therefore BD will be also equal to 5 units, and AC equals to 13 units, therefore AD will be also equal to 13 units, and the area of triangle ADC, that is the isosceles triangle, will be equal to the base of the triangle times the height over 2. It is the area of any triangle. The base of triangle ADC equals to DC. The height is AB. The height must create 90 degrees with the base, and indeed AB creates 90 degrees with the base. So the height is indeed AB over 2. So the area of triangle ADC equals to DC times AB over 2. DC equals to 10 units. AB equals to 13 units. So the area of triangle ADC equals to 10 times 13 over 2. 10 times 12 over 2. 10 times 12 is 120, and 120 over 2 is 60. So the area of triangle ADC equals to 60 square units. And we know that the radius of any circle that is inscribed by a triangle, like in this drawing, will be equal to the area of the triangle that blocks the circle. In this way, in this drawing we have triangle ADC that blocks this circle over the semi-perimeter of the triangle that blocks the circle, that is actually triangle ADC. Okay, I will repeat again. The radius of the circle that is blocked by triangle ADC equals to the area of triangle ADC over the semi-perimeter of triangle ADC. The area of triangle ADC is 60 square units. We have already found out that the area of triangle ADC equals to 60 square units. And the semi-perimeter of triangle ADC equals to the sum of its sides over 2. The sum of its sides is AD plus AC plus DC. That is to say, AD is 13, AC is 13, DC is 10. So 13 plus 13 is 26. 26 plus 10 is 36, and 36 over 2 is 18. So the semi-perimeter of any triangle is equal to the perimeter over 2. And the perimeter over 2 of triangle ADC is 18. So the radius of the circle that is blocked by triangle ADC equals to 60 over 18. We divided both the numerator and the denominator of this number by 6, and we got that 60 over 6 is 10. 60 over 6 is 10, and 18 over 6 is 3. So in conclusion, we found out that the radius of the semicircle, that is actually the radius of the circle and the semicircle, they are the same, is equal to 10 over 3 units, and therefore the area of the semicircle equals to pi r squared over 2. R is 10 over 3, r squared is 10 over 3 squared. So 10 over 3 squared is 100 over 2. And 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Then I presented to you how to find out the area of this semicircle according to the fourth method. In the fourth method, we actually defined this angle CAB is angle theta, and then we focused on the right triangle ABC. On the right triangle ABC, sinus theta equals to CB over CA. In the right triangle ABC, sinus theta equals to CB over CA. CB equals to 5 units, CA equals to 13 units. So sinus theta, according to equation number 1, is equal to 5 over 13. Then we focused on the green triangle, on the green right triangle. On the green right triangle, sinus theta equals to DO over AO. On the green right triangle, sinus theta equals to DO over AO. Okay, DO over AO. DO equals to R. AO equals to 12 over 12 minus R. So in conclusion, sinus theta according to equation number 2 equals to R over 12 minus R. And according to equation number 1, sinus theta equals to 5 over 13. And we have equation number 3. We created equation number 3 that states that sinus theta according to equation number 1 equals to sinus theta according to equation number 2. Sinus theta according to equation number 1 is 5 over 13. And sinus theta according to equation number 2 is R over 12 minus R. And they are equal to each other, of course. So this is equation number 3. So we multiplied equation number 3, and we got that 5 times 12 minus R equals to 13R. We open the brackets here. 5 times 12 is 60, and 5 times minus R is minus 5R. We added 5R to this equation, equation number 3, and we got that 13R plus 5R is 18R. In conclusion, we found out that 18R equals to 60. We divided equation number 3 by 18, and we got that the radius of the semicircle R equals to 60 over 18. We divided both the numerator and the denominator of this number by 6. 60 over 6 is 10, and 18 over 6 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3. Therefore, the area of the semicircle equals to pi r squared over 2. R is 10 over 3, so r squared is 10 over 3 squared. 10 over 3 squared is 100 over 9. And 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, thank you very much.